join. There is actually OSI model and protocols. First, I will explain about the protocols. So actually, we'll include in OSI model only, like a application layer part only. We discuss this one. Because time is lesser, so I will include in this OSI model only. Okay. Any which way, same thing to same. So one single layer. So we'll start with the OSI model. Open system, interconnect. Okay. So different networking models are there, like IPX, SPX, AppleTalk, okay, novel network, like different places, different types of networking models are came. Because these computers are invented, different organizations started using computers. They're connected with a different way of connectivity, and they started communicating between them. Okay, so depends upon their operating system, applications, devices, connection protocols. Okay, different protocols. Okay, they are use different kind of network models are came. Okay, all these models are came before OSI model only. Even the TCP/IP model which we are using is a TCP/IP model. That model is also came before OSI model. Okay, this OSI model almost like 1980s it is came. It is standardized by ISO International Organization for Standardization. This OSI model no one is using. It means they didn't implement in their, they don't implement like a TCP/IP. It's not implemented anywhere. But it is a reference model. Whatever the model existing earlier and whatever the type of operating system, applications, okay, what type of communication it can be, okay, what type of devices you are using, what type of cable connectivity you are using, what type of connectivity is there. So this OSI model gave a common reference model for all the different models. Learning of OSI model is very important. Why? Because of to understand the network, to create different network models, to create network things. Maintaining of network, very important one is of OSI model is maintenance of network. Troubleshooting network related issues. Troubleshooting network related issue, irrespective of what type of model or what type of devices you are using, what type of logical addressing you are using, okay, what type of physical address you are using, okay, what type of operating system, applications, protocols you are using. So for maintaining and troubleshooting of network, this OSI model understanding is very important. It consists of 7 layers. OSI model consists of 7 layers. These 7 layers are like this: application layer, presentation layer, session layer, transport, network, data link, and physical layer. Totally 7 layers. The layers, which is actually reverse order. The layer 1 is physical layer, layer 2 is a data link layer, layer 3 is a network layer, layer 4 is a transport, layer 5 is a session layer, layer 6 is a presentation, layer 7 is application layer. In some textbooks, it is like they started with the physical layer and with the application layer. Some places start with application layer and with the physical layer explanation. So if you are habituated to say like application layer to physical layer, already because you are in your engineering, CSC and IT, ECE, NTC, OSI model is there. So if you are already habituated to say application to physical layer, good. If you are habituated to say like a physical layer to application layer also, good. But do not interchange layers. Don't interchange the layers when you are telling about a OSI layers. Okay. How to remember all these layers? Only thing is first by heart, repeat yourself three times, 4 times, 5 times, 10 times. So then understand it. Another one is understand the way. understanding a way of communication. So then you will remember every layer it is. Following a shortcut, if you are well known about a shortcut to follow to tell this application layer, presentation layer kind of stuff, okay. If you don't know the shortcuts of telling this one, leave it, no problem. Don't learn the shortcuts right now. If you are already know, shortcut means okay. Not know, don't try again with the shortcut. Directly go with this layers only, because you have to remember first shortcut, then only you can come here, right? That's two of things you have to remember. Not required directly. You can remember. Okay. In this OSI model, the bottom three layers called hardware layers, top three layers called software layers. Of course, that's top four layers also comes under software layer parts only. The middle one, which is transport layer, is the heart of OSI model, also called as end-to-end connectivity, which provide error correction also. Okay. So when we are discussing about different devices like hubs, switches, routers, this part, okay, these are all hubs is a physical layer example, switches example of data link layer, hardware example of data link layer, router, which is hardware example of network layer. Okay. Each layer having a different functionalities, we'll see those things also. First is application layer. Guys, when we are communicating, all these are how we are communicating in the network from your sending to receiving side. Okay. How we are communicating. So for example, you want to communicate, right? That is the first thing is application layer. So first we'll start with the communication. Means to communicate different types of communication, mail communication, web communication, file upload, download communication, right? Or maybe authentication related communication, sharing of files, folders communications, okay, database access related communication. So different types of communication are there. Okay, so instant messaging kind of communication, ping related communication. See, when you do communication, so first important one is your application. It means through web browser, you can access website, right? I want to access a website. See, I use this web browser to access the website. YouTube.com. See, I need a web application. It is, what is our Google Chrome browser. I'm using Google Chrome browser to communicate, web related communication. Okay. Another one is like Outlook. Outlook is another application for sending and receiving mails communication. Okay. Of course, you are using web browser to Gmail purpose. Like it is a mail communication over the web related kind of stuff. Okay. So that's another type of communication. FileZilla. FileZilla is a FTP. Means file upload and download to remote site. It is FileZilla communication. PuTTY is another application for remote SSH and Telnet type of connectivity. Okay, MSTCS for remote desktop related communication. So different types of communication, different applications we use it to communicate. Okay. Okay. And so other side means this is a website I'm accessing. Other side, from where I'm getting this data. So that is from that related server. That's a web server. Web server related application is there. It can be a Tomcat server, or it can be a Apache HTTP server, or NGINX server. It can be there. I'm doing mail communication. Means other side of mail communication means mail server is there. It can be Microsoft Exchange, Zimra application can be there. Okay, so we are sending and as well as we are receiving. You're sending, so other side it is. So both side different applications for different purpose, different type of application are there. You're accessing remote Linux server. So your remote Linux server is SSH server. From your side, SSH client application, you use it. Okay. So It is application layer is all about application. Okay, all about application. Which application you are using for your communication purpose. First is application. Both client side and server side applications are both end devices. You are communicating means from one to another one, from this system to other system. Okay, from client to server. Both side, you need an application to understand what type of communication. Another one is protocols. So what type of communication? To do what type of communication you are using an application, but in that application also you have to specify what protocol you need to for communication, right? Application is important, protocol also important. If you see, it is HTTPS protocol. HTTPS protocol. HTTPS protocol, we use it. Different protocols. I will use extra. It will provide lot of protocol things. This is an application to communicate different systems with the different types of communications. So it is SSH based communication, TELNET, RDP, VNC, FTP, SFTP. Okay, so different types of communication I can able to do it through this application. Okay, so application layer is all about what type of communication it is, based on what application you are using and what protocols and port numbers you are using. Okay. I'm using MySQL Workbench. It's a MySQL client application. Okay. And coming to the protocols and port numbers, that's just yes, application layer is about application and protocols and their port numbers, mainly protocols. What is the protocols? Protocols define what type of communication. What communication you want to do it? Mail communication, web related communication, file upload download communication, remote access related communication. Okay. Remote access communication, remote authentication communication. Okay. DHCP, DNS type of communication. Different types of communications. Okay. So protocols defines what type of communication you are doing with your other system. Okay. So here it is different protocols, HTTP, HTTPS, both protocols for web related communication. HTTP, HTTPS, both are for web related communication. HTTPS is HTTP or SSL, means it's a encrypt HTTP data. Only HTTP protocol means data is open, means anybody can see your data, anybody in your network can able to take your data and see your data. Possibilities that manipulate your data is possible. But S means it is encrypted data, so no one knows what data you are transmitting. Okay, like your WhatsApp end-to-end encryption, end-to-end encryption. So what is that meaning is you can able to see your data, your pictures, your videos, your messages. You can view, and other side recipient can able to view. If I capture your packet while you are sending and receiving, I can't view any data in it. I can't understand what is the data you are sending and receiving because data is encrypted. That's why the most of current right now websites are HTTPS type. Initially, they are given for only banking purpose, then email communication purpose. So later, most of the things are now HTTPS type only for securing their data transmission. For example, this is just a notes type of document, right? This is just a notes. Means I want to learn about Python. So what is the requirement of encrypting it? Okay. But still why it is encrypting using HTTPS? Okay. So why? Because of while I'm transmitting and receiving data, someone can manipulate certain part of data. Possibility is there. Okay. So I will get a wrong information in it. Okay. So that's just the about everything is HTTPS right now. Only few sites still working with HTTP. Okay. Or maybe localized one, means only in my PC I have one website myself, that's someone or two, that's all HTTP only. That's my local. I'm only accessing it. No others can able to access. Okay, that is so web related communications. FTP, to upload a file and download a file from remote server. Okay, you can upload a file and download a files. SSH, Telnet, and RDP all are remote access purpose only. RDP is GUI based, remote desktop related, entire desktop screen and everything you can able to access, mainly used in Microsoft RDP protocol. Telnet and SSH, again SSH and Telnet both are CLI based. SSH is encrypted and Telnet is not encrypted by default. Okay, no encryption by default, this is encrypted by default. Okay, both are for remote access purpose, remote Linux servers or remote devices. We can access through Telnet or SSH. We can connect it, log in it, and we can do our work configuration. We are seeing at Windows as GUI, okay, but Linux is CLI, Unix is CLI. You want to connect Unix or Linux, you can connect from your system through network using SSH protocol, and we can do what are the installation you want to do, configurations, user management, disk management, everything you can connect remotely. That is SSH. Okay, these three protocols, SMTP, POP3, and IMAP, these are a mail communication related protocol. When you are sending a mail, the server should understand now you are sending request. Means SMTP protocol for sending mail. Okay, you want to see your mails. You open a Gmail and then you will see your inbox mail messages, right? So you are retrieving a mail from the mail server. Mail server contains your mails. Just you are open, so then you can able to see all your mails. Okay, that is a retrieval mail. Okay, so for that one you may use IMAP or a POP3 protocol. Easiest example, not only web browser, guys. In your mobile phone, you have a Gmail app. Gmail app is there. So in this Gmail app, it is when you given an email ID itself, it is configured. Okay, you are able to send and receive a mail through Gmail app, right? Same thing like an Outlook in generally. Okay, so you can send and receive mail. For sending, it uses SMTP protocol. For retrieving, like you received an email, you want to see your new mail, what you are in your mail server. So it send a request with the POP3 or IMAP. Generally, IMAP it is used to get your new mails to your Gmail app. Okay, so these are the mail communication related protocols. TFTP, Trivial File Transfer Protocol. These protocols for usually remote configuration, upload or downloading remote configuration file, backup remote configuration, things like that. Mainly used in with POOTP protocol for installation of multiple devices through network. OS we can install with the 10 systems at a time. Through network we can install. That time we can use it. Remote device configurations, remote configurations, files uploading, okay, auto configurations. That time we use this trivial file transfer protocol. You know, already DHCP, we told about so many times of DHCP. DHCP is a protocol, usually it is for assigning IP address or configuring IP address to the client devices. So my PC got an IP address from DHCP server. Okay, to that one. So I need a DHCP type of protocol communication is required. I open this Java tpoint.com. Now name is changed to tpointtech.com. Okay, instead of Java tpoint.com, it's tpointtech.com. I should communicate to youtube.com, facebook.com, or anything with a mail IP address only. But I didn't give an IP address, I given a name only. So what happened? Our system send a request to the DNS server. Okay, if you check your IP address, their DNS server address is also showing. DNS server address is also showing. Okay, so what is our system? It send? System send a request to that DNS server. I want an IP address of this tpointtech.com. I want a IP address of www.t.tech.com. Then DNS server will give you IP address of t.tech.com. Okay, so that is, then you know the IP address, system knows IP address, then started communicating with that IP address. Just like a mobile phone contact list. Simple, your mobile phone contact list. You have a name and phone number is there. Your mobile having a phone number is there. Already you are having one phone number. That is given by your service provider, right? Like your laptop having an IP address, which is given by DHCP server. But you want to communicate someone, but you don't know their phone number, but you are already feed into your contact list. So you will open the contact list, click on their name, and call will go. But actual call is going to phone number only, but display the name only. So I'm calling to my mom, so it will show mom. But actually, it will call goes with the phone number only. Okay. Same way, you're trying to open something, w3schools.com, gmail.com, facebook.com, youtube.com, www.youtube.com, studio.youtube.com, docs.google.com, meet.google.com. So when you're trying to communicate to that specific things, so what happened? So you don't know, your system don't have that IP address. Okay, we didn't make any contact list here. So we will ask the DNS server, and system went to the DNS server for just send a request to DNS. I want this specific server's IP address. Then we'll get an IP address. We'll communicate with IP address. That's what it is. DNS. Where are we here? Here, right? That's a DNS. It gives IP address of a specific host or a server in the domain to our client PCs. Okay, someone's IP address, you will get it. Okay, NTP, Network Time Protocol. It synchronizes time with a time server. Okay, I'm getting this time, of course. Okay, I'm getting this time from time.windows.com with from that server only. This time is came. So first my servers, my PC send a request to the time.windows.com with my time zone. So based on my time zone, what is the time zone based on its server's time, it will configure that one. Another one is KERBEROS. KERBEROS. KERBEROS and LDAP both are for authentication. Login authentications, right? Username, password authentication kind of stuff. We do it. Authentication and authorization related protocols it is. SNMP protocol, simple network management protocol, mainly used in a monitoring purpose. So in your organizations, so you have a lot of servers, routers, switches, so many devices are there. We want to monitor it, how it is servers are going on, whether it is on or off kind of stuff, or maybe what is their details, what is their process running in it, how much CPU utilization, memory utilization. I want to get that details into my dashboard, into my system, to my monitoring tool. So what type of protocol to get that information we use it is SMTP protocols. Okay. Not only these protocols, guys, there is so many protocols are there. These protocols are, each protocol is for a type of communication purpose. Okay. So mail communication, remote access related communication, authentication, time synchronization, web related communication, file upload download type of communications. So different types of communications, different types of protocols we use it. Understand, guys, protocols?
Yes, sir.
And each protocol having certain port numbers. Okay, there are a lot of port numbers also available. Okay, the protocols we in an application, so we see about application and protocol. In a system, based on your protocol, based on your communication, or based on your connectivity, it chooses its port numbers. So certain protocols having certain type of port numbers. For system understanding, it use port number for connectivity. we for our understanding protocol, for system understanding, it's a port number. So application layer is all about application, server side, client side, and dot type of communication. Based on that, you use an application. Based on that, what protocol you use it. Okay, and based like what port number you are using to communicate. This is application layer. Most easiest one is presentation layer. Okay, because presentation layer is only 3 points only there. Okay, encoding, decoding means you're sending or receiving data. So when you are sending a data, okay, whether it is web communication, mail communication, or anything, you're communicating, right? While you're sending data, data is in different format, text format, picture format, video format. Okay, I uploaded my video to YouTube. So it is, I'm sending a MP4 format file. Okay, different format of data I'm sending. Okay, pictures, thumbnails, right? Text, I will put it. So when I'm uploading it, okay, to YouTube. So what happened when I'm sending a mail, PDF, I will send, documents, I will send it, right? So different types of communication you are doing. HTML type of data we are sending. Different types of data we are sending. So what is this? Happen, it encoding your data. It convert whatever the format of data into the ASCII format, American Standard Code for Information Interchange format. Okay, it convert your data into ASCII format, which is direct EXA format. It is easily understand by your system. Okay, so that is first is encoding. Okay, while you are receiving, it is decoding. Your encoded data, you will decode it while you are receiving. When you are sending, you are encoding it. Next is data is used. Then it will compress the data. You try to compress the data to make it a smaller size of the data, compress the data. And next one is encrypt the data. So we are using HTTPS, SSH protocols. Okay. So that is like a data encryption is required. It will encrypt your data to protect your data from external access or external threats, external stealing of data, external manipulating of data. Okay. For that one, so what it will encrypt data. So presentation layer is very simple. It is for presenting data. It's about how it is presenting your data. Okay. Application layer, presentation layer. Okay. So application layer is all about your application, protocols, and port number. How you will send, how will you access, how will you receive all these things by your application, protocols, and port numbers. Presentation layer data. It encode your data and decode your data while you are receiving. It compress the data while you are sending and compress and send, and while receiving, decompress. Encrypt the data while you are sending, encrypt the data while you are receiving, decrypt the data. Next, session layer. Session layer is in a textbooks and are very small, but it is session layer is very important. So you are sending, it means whether you are sending a request or maybe you are sending a data. So it will attach with a session ID. Okay. So while you are transmitting and receiving entire thing, for example, you want to download a file from remote server. So you request to download and you are downloading. So till it is completed, or you open a website. So till it is website is completely open. You open your Gmail account. So completely that entire information is loaded. Till the time session must be active and entire transaction must be done in the same session only. Same session only. Otherwise session will be disconnected. You purchase to railway tickets or maybe Amazon, Flipkart, right? You select an item, you add to cart and you buy. So when you click on a buy, so that time onwards, it is very crucial from buy onwards. When you click on a buy, then it will take you to the address confirmation, then it will take you to the payment. It's very important, it's a payment. You given your card details and then you say okay, then bank OTP and enter OTP, click OK, and it will rotate now. It will tell do not press the back button or refresh. If you back button or refresh, what happened? The session will be changed. It will become another session. If this other session means you don't understand the transaction related, it is means money is detected, but where to send. Okay. So session is not changed while it is returning. So it will send information to bank to direct the money and come back to your Amazon and it confirm your order, right? But meantime you refreshed. So what happened? Money is detected, but it is unable to send to it because session is changed. So entire transaction must be in the same session. So it will create a session ID. Okay, it will add authentication and authorization information, which user is accessing, is allowed to do access or not, authentication and authorization information. Next, it will maintain your session till the session is completed. Maintaining of session. It create a session, maintain the session, and terminate the session. Okay, it create a session means session ID will be created and maintain the session till the session is completed. And once it is completed, it terminates the session. And also it is manages multiple sessions, different types of communication. So it will make a different multiple sessions, okay, to make it different type of communication in it. So this is a session layer. Biggest one is transport layer, remaining as small layers on. But every layer is important, guys. Up to now, we see 3 layers. So remember, guys, PDU. PDU means packet data unit. PDU means packet data unit. From your application layer, whatever the data in this application layer, part of data, okay, what protocol, what application, what data you are sending, what data you are want to receive, or like that. Whatever it is, your data in this layer, okay. So that is PDU, okay. So the PD of application layer, packet data unit means what data in that layer. Okay. So for application layer data is called data only. The PDU name is data only. Again, presentation layer. In presentation layer, data is encoded, encrypted, compressed. Okay. That PDU means data which is encoded and compressed and encrypted. Okay, that entire data we call it as a one PDU. That's layer data. Is layer wise data. Every layer, whatever the layer it is, the layer data is called PDU. Okay. So what is the data after completion of these 3 things is called data only. Okay. Data. Session layer. Session layer, the session ID will be created and maintained and terminated. Authentication information also include to your data. That PDU, we call it as a data only. Up to here, it's a data only. Because the next is will be changes transport layer. In this transport layer, we take this data and chop the data into small pieces. We chop the data into small pieces. This process called as segmenting. Segmenting. And once you segment the data, it put a numbering on it. Numbering and sequencing on this parts. Numbering and sequence. Segmenting, numbering and sequencing will done by transport layer. Okay. Small pieces. Cut the data into small pieces. Okay. And take one by one piece called a segment. Okay. You take one by one piece, add a TCP header on it. This TCP header contains what port numbers you are using, either TCP type port numbers or UDP type port number you are using. Okay, TCP type or UDP type protocols you are using, what protocols you are using, and windowing information means how many packets you are sending right away. That packets, how many packets you are sending, window size is included, how many, what is the segment number you are sending, and what is the segment. This is entirely called it as, okay, yes, sorry, up to segment number. This entirely we call it as a TCP header. And this TCP header is added to your segment. Like this, so many packets will be created. That's why this is called a PDU. This is our PDU now. Okay. What is transport layer PDU? Transport layer PDU means it take the data, chop the data into segment. Okay. Add that sequence and numbering. Okay. To the segments, and your protocol data means port numbers, encapsulating TCP type and UDP type of protocols. Port numbers will be added there. And how many packets you are sending one by one to the destination right now. So that is called a window size, or a flow control information is added. And your segment number and sequence number is added. So this is our PD, okay, our packet data unit from transport layer called a segment. So one point we have to add again, guys, TCP UDP. So again, another common question and compulsory question. TCP UDP, transmission control protocol, user datagram protocols. TCP is a connection oriented protocol. Means when you are sending a data to the destination, first it will check the connectivity, is the destination is available or not. Check the connectivity to source to destination, connectivity is there or not. And UDP, it does not check any connectivity to destination. Okay, you don't check any connectivity to destination is there or not. Okay, you don't check any connectivity. Initially, before sending, you don't check any connectivity. So that's why it is TCP called a connection oriented. Means TCP types of protocols check it's whether it is connection is there or not to the destination. UDP don't check it. That's why it is connectionless protocol. Okay, connection oriented. Next, it is reliable. It is non-reliable. Connectionless. Okay, non-reliable because there is no acknowledgement where there is no guarantee of delivery kind of package. TCP is a acknowledgement based, and UDP no acknowledgement based. TCP protocol, when it is send a packet to destination, destination will send an acknowledgement to the source. Meaning is source understand destination is received it. So source send a packet to destination, destination send acknowledgement. So if source send a packet and destination fail to give a acknowledgement, what happen? Again, source will send the packet again. Okay, so that's what it is. Transport layer correction oriented. It will, if any missing packet is there, it will resend it again. Okay, so TCP, what it will do? So connection oriented, reliable, acknowledgement based. Mainly all these are because of acknowledgement based only. Source send a packet to destination, destination received a packet and send back and give a acknowledgement to the source. Source understand destination is received or not. So this is TCP type protocol. UDP type protocols. UDP type protocol. Source send a packet to destination. Destination is received a packet or not, source don't know. Source will keep on sending a packet. Even destination not received it, we don't know. So then we have to keep on sending a packet. Okay, we don't wait for in UDP, it won't wait for a UDP type protocols, don't wait for any acknowledgements here. It will keep on sending a packets. Okay, that's it is faster than compared to TCP. TCP is slower. Why? Because it waits for acknowledgement. Again, acknowledgement. It will receive acknowledgement parallelly. Okay, so that's it is little slower, but it is not a exactly slow kind of stuff. We should not say, but as some textbooks saying slower because of acknowledgement. Really, it is not a slower. Main important is TCP is reliable. Why? Because of source knows destination is received a packet or not. And it is connection oriented because of two-way communication is there. Source to destination, destination to source. So packet delivery guarantee is there. Okay. And acknowledgement based, of course, TCP. We learn about lot of protocols, right? So HTTP protocol, FTP protocol, SMTP protocol. So these are examples of TCP type protocols. Actually, we discussed about the protocols. These protocols are either TCP type or UDP type or both also there. Okay. So for example, TFTP, Trivial File Transfer Protocol, is UDP type protocol. DHCP is UDP type protocol. DNS, UDP type protocol. And DNS is both protocol. DNS is TCP as well as UDP type protocol. Okay, guys, some protocols are TCP type, some protocols are UDP type. TCP type protocols are reliable, connection oriented, acknowledgement based. Source knows destination is received a packet. How it is? Destination, when it is received a packet, it will send an acknowledgement to the source. UDP, connectionless protocol, non-reliable, and no acknowledgement base. Source send a packet to destination. Destination won't give any acknowledgement. So source don't know destination is received a packet or not. So, okay. That's a TCP UDP. Guys, understand difference between TCP and UDP?
Yes, sir.
Yes, sir.
Very good. Very good. Okay. It's a compulsory part. That's it. Okay. Again, we'll come back to the transport layer. In transport layer happen. So data is segmented and sequence numbering on each part of the data, and TCP header is added to your segmented data. What is the contents of this TCP header? Contains TCP, UDP, protocols, their port numbers. Okay, and window size. What is the how many packets you are sending right now, and what is this packets related number? This particular segment number is there. So that is included in this TCP header. This PD we call it as a segment. This total we call it as a segment. And this segment will send to the network layer. Send to the network layer. What is this network layer? Is only 3 layers, simple layers only. Okay. This network layer, 2 points are there. One is routed protocols, another one is routing protocols. Mainly it use network layer is all about logical addressing. Logical addressing. First is logical. Routed protocol means logical addressing. We use logical addressing is IP address. In different protocol suites, they use different IP addresses, right? Different kind of logical addressing. But we are using TCP IP. TCP IP means it's a IP address is a logical addressing we are using. We know IP address only, logical addresses, remaining we don't know. So we leave about that one. So what it will happen at a network layer? In network layer, the source IP will be added. Okay, you are sending means your IP address to whom you are sending, that is destination IP, and okay, what is your segment? Your segment is added. Source IP, destination IP to your segment is added. This is a network header is added to segment. Network header contains source IP, destination IP, and routing information. Routing information means how to reach the destination, which way the packet has to go, which adapter packet has to go, which default gateway packet has to send. Okay. So if destination is in your network, your own network, in your LAN, means it has to know which way it is, that which adapter, and then it is which way it has to go, right? If it is destination not in your network, it is outside of your network, packet has to send to default gateway only. Packet has to send to the default gateway only. Okay, that path it will add it from there. So how to go? So that paths will be added to your packet. Source IP, destination IP, routing path will be added to your segment. That is called our network header. The outcome is called. So this is again network layer. The PDU, we call it as a packet. Okay, we call everything as a packet only, but originally packet means contains source IP, destination IP, routing information, and your segment information is also there. That is network layer. So this is what it is. It's a packet. This is the packet. This packet is sent to the data link layer. In data link layer, there is two layers, LLC and MAC layer. You're sending a packet over WAN connectivity. So packet is travel from your PC to your router and then outside, like to whom you are communicating based on that, right? If it has to send to the WAN, means public, like a WAN connectivity, through WAN connectivity. So WAN protocol information is added. WAN related information is added, like PPP, OE, point-to-point over Ethernet type of WAN protocol, MPLS, frame relays. Nowadays, frame relays are not using. Okay, frame relays, PPP, MPLS, SDLC, SD-WAN. Nowadays, we are using SD-WAN for MPLS. Current one is MPLS. GP-on, fiber optical, GP-on, DSL, ADSL lines we are sending the packets, right? So that is LLC part. In case you are communicating in a local network, then MAC information is added. Your source MAC address will be added. Destination MAC address is added to your packet. Okay. Plus a CRC, cyclic redundancy check. Okay. Generally, LLC link, logical link control. This is actually used for a link between your hardware layers to software layers, means above network layer and above layers to bottom physical access layers. Okay, that we make a link between them, as well as this LLC also indicating WAN protocols. When you are communicating over WAN, LLC is there. Other than that, there is no LLC part. Only this link between the IP address to MAC address communication only. ERP related protocols, it will work there. So what happened here? So in a MAC layer, so what happens? Source MAC address, destination MAC address, your packet and CRC is added. So this is called a frame. This PDU call it as a frame. This is the frame. Okay. Okay, what is this CRC? Cyclic redundancy check. It's a checksum error. It is a checksum error. So what is this checksum error? Checksum, not checksum error. It's a checksum. It's like it takes some part of your data only. Take it from your whatever the data it is, right now it is. So it takes some number from it, check some number from it. Okay. It is used for a verification of data. So when destination received a packet, while you're sending, so a packet has to travel through lot of things. When destination is received, It verify the data. It check the data whether data is safe or corrupted. Data is safe or corrupted. Okay. If it is small corruption, no problem. It's try to regenerate the data. Otherwise, it drop the packet. Data is corrupted, not required. Okay. So CRC use it to verify the data. CRC checksum data is added here to verify the data at destination. Error correction. That's a data link layer use error correction. Okay, this is the right now frame. Source MAC address, destination MAC address, packet CRC. These two are called the data headers. CRC is a data tail, and finally we have a packet. This frame is sent to the physical layer. Physical layer. Okay, frame sent to the physical layer. In physical layer, this frame is converting to bit stream. Converting to bit stream means like a binary form. Okay, again. Physical connectivity. Physical layer means mainly physical connectivity. For example, you are using okay, Ethernet card. You know our Ethernet, fast Ethernet, right? That is electrical signal. Okay, electrical signal. It convert your bit stream. If you are using Ethernet card, it will convert into a electrical signal. Okay. If in case you are connected, you are using you're using a HBA type, means like a fiber optical type of connectivity. Then it will convert that based on that media, that's physical adapter. So it will convert your bit stream into light waves. Okay. In case you are connected to Wi-Fi, so Wi-Fi wireless type of adapter it is. Your adapter is Wi-Fi wireless adapter. Then it will convert into radio signal. Okay. So this is what happened to your total voice center. So application, presentation, session, transport, network, data link, and physical layer. Okay. Everything I try to keep it in one place by writing like that. It's random. Okay. So guys, again, application layer, presentation layer, session, transport, network, data link layer, and physical layer. So application layer is about how what application you are using to communicate, what type of communication based on what application you are using, and what protocol, what port number you are using. Okay. So that is application layer. What are the protocol, what are the application you are using, but what are it is, there is a data. It convert the data into ASCII format, means encoding the data. Then compress the data, encrypt the data. That data is added with a session ID. It creates a session, new session will be created and maintain the session till the completion of communication. Entire transaction is completed. Till that time, the session has to be maintained. It includes authentication and authorization information. Plus, your data is in the different sites, like you are having a pictures, you have a text, you have a different set of data is there. It combine all the data together. It connect and combine all the data, which place pictures are there, which place document is there, which place video is there. So while you are sending, it will combine all this data together into the segment. Okay. So translation into the session layer also combine all this together, connecting. And transport layer, what are the data it is from your segment layer, is this called a data only. That data is segmented, and numbering and sequencing are there. Numbering and sequencing. Okay. So then it add your TCP and UDP protocol port numbers to your segment. That segments will send to the network layer. In the network layer, sorry. So in the network layer, source IP, destination IP, and routing information means the path how to reach the destination will be added at network layer. That outcome we call it as a packet. The packet sent to the data link layer, source MAC address, destination MAC address will be added plus CRC. CRC checksum data is added for data verification purpose, error detection purpose. Okay, so the whole we call it as a frame. In physical layer is physical connectivity. So if that entire frame is converting to bit stream based on your physical connectivity. So it can be converted into radio waves like 2.4 gigahertz or 5 gigahertz, what type of adapter you are using. Light waves based on if you are using fiber optical type of adapter. If you are using Ethernet or fast Ethernet, then it is converting to electrical signals. So data is manipulated that time. And other side means data is receiving at physical layer on the other side, destination. And at the destination, it converts whatever the signal format it is, it converting to again into the frame. And frame is sent to the data link layer. So data link layer check the source MAC address and destination MAC address. It take, for example, this is PCA and this is PCB. It check the MAC address of A's and B's also. So it is suitable, like if it's same PC, B MAC address, accepted. And it will take the A PC MAC address and keep it aside. Okay, I will tell why what it's happening. Okay, so it verifies the data using CRC. It check the data, whether the data is good or not. And take the source MAC address, put it one side, and check with the destination MAC address with the B's MAC address. So it is good, then it will accept the packet, otherwise drop the packet. Next, at network layer, it check the, so outcome is, what is the middle, which is packet, right? That packet contains source IP, check the source IP, means A's IP, and destination IP, and we got a segment. And we keep the source IP aside. So this source IP means A's IP address and A's MAC address kept in a table called ARP table. At B side, it kept in a table called ARP table. So this ARP table, A's IP address, A's MAC address is stored in the ARP table. It used for a future use of communication. Okay, because destination MAC address is required that time we use it. ARP, address resolution protocol, source IP, IP address and MAC address mapping. Again, transport layer. Again, we got a source IP, destination IP, segment, right? And these segments are collected here. So one segment came, and next transaction, another segment is came. Another transaction, next segment is came. Okay. In a transport layer, it's end-to-end connectivity because at transport layer, we chop the data. Again, other side, a transport layer, we assemble the data. We'll put all the segments together and check their port numbers and check their window, how many packets we are able to receive. What is their segment number? Okay, we'll assemble all segments at a transport layer. Okay, once it is assembled, and check the error correction, any segment is missed, so then we will wait for another missing, and we rearrange the data because segments are maybe you received 1 2 3 5 7 8 9 2 4 like that you will receive it, so then maybe it will reassemble the data again. Once it is done, it check the this, what is S? So session layer. What is its session ID? What is authentication? Authorization information is given. Okay. What is the data is arranged? What type of data is, where is the data segments are there, like this arrangement is there. Okay. It will check it. And then it is going to the presentation layer. Data is encrypted. Here it is decrypted and decompressed and decoded. And again, entire data is going to the application layer. Based on what type of communication, other side, other application is also there. No? That application understand based on your protocols, port numbers, and your data will understand what the type of request you are sending or what type of data you are sending. It process that data, okay, and it will giving a reply after receiving. Again, same, that application to presentation, session, transport, network, data link, physical. As I said, at this data link side, okay, it has to give destination MAC address. So then this will take it from the ARP table, destination MAC. Again, physical to data link, network, and finally application. So this is how we are communicating source to destination, destination to source. Okay, guys, understand your OSI model?
Yes, sir.
Okay. Without your consent, I told completely, but important, guys, 7 layers are important. Each layer process is important, and that the PDUs are important, like a transport layer is segment, network layer is called packet, data link layer is frame, physical layer is bit stream. These are all important. But, okay. And each layer, what is its process, what it will do. TCP UDP difference is very important in here. Straight questions, no bending, nothing, straight questions. Okay. TCP IP, earlier this is called a DoD model, Department of Defense model, used in a defense places in US. Okay. Later it is given to the public, so it's become public model. We are all communicating using a TCP IP model only. This is just a comparison, guys. It's not like how TCP/IP came from YSA. No, TCP/IP came. This DoD model came before YSA model came. Okay, and YSA model is the reference model, just for comparison of this TCP to YSA model. In TCP, application layer do 3-layer duty. Application, presentation, session layers duty means their function will done by this only single application layer TCP/IP model. And transport layer is a transport layer, same segmenting process only. In TCP/IP, internet layer, in voice model it is network layer. In TCP, network access model, that is network access layer, that is network data link and physical layer, two layers function it will do it. I think I've written someplace it is, you have NIC card having a MAC address. NIC card also physically connected. So then we can say it's a network access layer type. Okay. So there is a troubleshooting and some other commands also given. Troubleshooting with the OSI models, like you got a physical, like you're not getting connected to your remote system. So what you will check? Physical connectivity. IP address you will check it. Firewall is blocking your network, like a port number wise, any port number services, protocols, port number services, is any firewall related connectivity is having an issues, or encryption related issues are there. Session timeout is happen. Session timeouts are happen. Authentication related issues are there. Application related issues also there. Okay. So we can understand from output what kind of communication, based on that, which part we can able to troubleshoot it. Connectivity is there, both are communicating, but you can't able to transfer the data. It means can be application layer, or maybe it is some encryption part of communication or firewall related issue. Okay, like that we can understand by understanding OSI model based on what is our network issue. So we can check using this help of OSI model, which part we have to check directly. So as I said, in our earlier days, everything is from scratch checking, from basic connectivity to everything. Now it is not like that. Even hardware problem or networking problem or server related application related issues. So based on what issue, we'll check that area part only, not from the scratch. Not required always. So I mentioned some networking related comments and some ping related information. What is ping? What is trace RT? What is how to check the connectivity troubleshooting also. It's already 1:15. It's around lunch break. So we'll see next time, maybe tomorrow. If possible, I will explain these things also. Okay.
Okay, sir.
Already. Some person read, guys, after your works are completed also. Just read. That's it for today. See you tomorrow.
Thank you, sir.
Thank you. So you do presentation also very well.